In this video, we'll be looking at linear combinations of vectors and discovering the magnitude of those vectors together with the angles they are making with the x-axis. I'll do some of this, but not all of it, and leave the rest for students to do. Okay, so what are we going to do? Firstly, we're going to start off nice and easily. We're going to find the magnitude of vector A. Well, we know how to do that. That's just a exercise in Pythagoras, isn't it? So we know that the magnitude of A is simply going to be the square root of the I component squared plus the j component squared, and that's 25 plus 4 is square root of 29, which cannot be simplified, so we're done. What about C minus D? And I'll leave the ones in the middle for you to do. C minus D. Okay, so where is C and where is D? Well, the magnitude of C minus D is going to equal the magnitude of, let's just write down C, which is 2I plus J, I think, yeah, plus 2 plus 1K. And we are subtracting D, so minus, that's a negative I, plus 4j, and plus 2k. Okay, so what does that come to? Well, I believe it comes to this. Getting the i's together, we've got 3i, and we got minus 3j, I think, because it's 1j minus 4j minus 3j. And what have we got for the k's? It's 1 minus 2, so it's negative 1k. Otherwise known as just k, and we need to find the magnitude of that in the usual Pythagorean way. So here we go, it is the square root of, coefficient of I is 3, so it's 3 squared, plus negative 3 squared, plus negative 1 squared, and that is going to come to the square root of 19. So that's the magnitude of C minus D and A done. You might want to pause and have a go at parts 2 and 3. Okay, let's get back to it. And I think you'll find the answers square root of 13 for part 2 and the square root of 97 for part 3. All right, find correct to 2 decimal places the angle which each of the following vectors makes with the positive direction of the x-axis. Again, I will do the one relating to vector A and the one relating to vector C minus D. Okay, what have we got? Well, we're interested in the angle the angle that's made with the x-axis. So really it is the I component that I am going to be interested in. Okay, so we are going to say that in relation to its B1, that the angle is going to be, well, we're going to say cos alpha is equal to, now it's 5, because in the I direction we got 5 units, over the square root of 29, because that's the magnitude of vector A, and to 2 decimal places according to my calculator in degrees mode is 21.80 degrees to 2 decimal places. Okay, now C and C minus D, that vector there. That vector you may remember, so for Roman 3, vector C minus D was equal to, from the previous page, I think it was 3I minus 3J, and then minus K. All right, so what are we doing again? We are, okay, so it's the x-axis, so once again we are interested in that 3 there. So cos alpha is equal to 3 over the square root of, the magnitude was 19, wasn't it? 19. So therefore alpha, sorry, I should say therefore alpha equals, shouldn't I? Alpha equals, and according to my calculator, it is 46.51 degrees, again, 2 decimal places. You might want to have a go at Roman 2 there, and as you can see, I've slipped in the answer. Make sure you can get that. Thank you for listening.